Hi, my name is Luke Jurasek, and today I'm going to be talking about element number 22, which is known as titanium. The element of titanium was technically first discovered in 1791 by William Gregor, and also discovered by Martin Klaproth in 1795. Gregor found it first, after he discovered some magnetic black sand that contained iron and a different, unknown at the time metal. It was Klaproth, though, who gave it the name titanium, named after the Greek deities. It was not until 1910, however, that the name titanium became really official, when Matthew Hunter isolated titanium for the first time and decided to call it by that name. So, Gregor is credited with discovering the metal, but Klaproth is the one who really managed to name it. Some interesting facts about titanium. Titanium is silver colored, has a low density, and a high strength. As you can see highlighted, it is 2 times as strong as aluminum while only being 60% more dense. This allows titanium to present itself as a strong structural metal. It is also the 9th most abundant element in the Earth's crust, occurring naturally quite often. However, it is always found bonded and does not occur naturally pure. To add to its structural resume, titanium is highly resistant to corrosion, allowing it to be used extensively in corrosive locations like the oceans. The main use of titanium is in titanium dioxide, which will be discussed in more depth in a minute. One important note about titanium is that pure titanium is reactive, but it creates an oxide layer on its outer surface to render it inert or non-reactive. Titanium's chemical facts. So, here are some of the chemical facts associated with titanium. It has a high melting and boiling point as a transition metal, melting at 1,668 degrees Celsius and boiling at 3,287 degrees Celsius respectively. It has 22 protons and 22 electrons, with a molecular mass of 47.867 grams. Titanium's density is where it proves its worth, though. It has a fairly low density in comparison to other metals, at 4.507 grams per centimeter cubed. Titanium's strength to density ratio allows it to be one of the strongest naturally occurring elements on the planet. It also rests in the 4th row and 4th period of the periodic table, identifying as a transition metal. So, how is titanium used today? Titanium is mostly used as titanium dioxide, a white pigment with some structural properties. Its architectural capabilities allow titanium to be perfect for use in aircraft and spacecraft, and its resistance to corrosion makes it perfect for naval ships. The general rule for titanium, though, is that it is ideal for uses that require structure that are both lightweight and strong. This includes hospital equipment, guns, and even football helmets. Body piercings, too, are made of titanium, thanks for the oxide layer that it creates around itself, allowing the metal to become inert. The first picture is of an airframe for an airplane. Obviously, airplanes need to be light and strong to fly, of which titanium perfectly fills that role. Then you have an ear piercing, which are often titanium due to its status as inert and non-reactive. After that, some hospital tools since they need to be both light and strong, and finally a flying missile for the same reasons as the airplane. Flight requires both lightweight and strong material. So, finally, titanium dioxide. When you first think of titanium, the idea that pops into your head is a super strong metal that you hear about being almost indestructible. However, that image is pretty far from the truth. 95% of titanium is used in a powder form as titanium dioxide. Titanium dioxide, as the name implies, consists of 1 titanium atom and 2 oxygen atoms. It creates a white pigment and is occasionally used to strengthen things like fishing rods. It is mostly used, as the list at the bottom states, in paints, lotions, sunscreen, cosmetic industries, toothpaste, foods, and some baked goods. So, no, titanium is not the indestructible supermetal pop culture might make it out to be, depending on the movies you watch. In fact, the majority of it is not even used to build things. However, when it is used structurally, some incredible things can be the result, like space travel, flight carriers, and hospital care.